new project there, CSE114. I think it will be week 14. Okay, so let's go there. New file, new Java projects, and then CSE114 week 14, lab 1. Okay, and then let's create a new project, new package there. So let's just call that maybe bank. Okay. Call that bank. And now I would like to reuse the code from last week. So if you can go to last week's week 13 lab 2, the exercise there. Remember we actually got two versions for both examples, especially the one for bank. So we got a package there called bank version 2. So if you go there and then select all the files there, so you got account, you got bank app, also you got invalid transaction exception. Okay, I want you to edit and copy, and then go to the bank package we just created, and say edit and paste. That's what I want you to do. Okay, so now we should have account, bank app, and invalid transaction exception. That's what we have. Okay, we are reusing last week's code. Okay, so now let's see. If you try to recall what we did last time, if you go to the account class, you can see that in the account class, we actually say the deposit and withdraw, they might throw some kind of exception. So you can see as part of the signature for deposit, the deposit might throw invalid transaction exception. And also withdraw might also throw the same kind of exception. So when do we throw them? So if you look at the code for deposit and withdraw, you'll see when the amount is negative, then you will throw the invalid transaction exception objects from the deposit. In the case where the amount is actually negative, or if the amount is positive, but the amount is actually way too large for the current balance, in which case you will also throw the invalid transaction exception. Okay, that's what we had last time. And if you see how we define the invalid transaction exception, if you go there, you will see that the invalid transaction exception clause extends the exception clause. Okay, as always you have to do to extend the exception. As we said from the lecture today, so whenever you actually extend your exception clause from the exception, so let me say it again. Whenever you extend your exception subclass from exception, in this case, the exception must be handled somehow. Otherwise, your code wouldn't compile. If you don't want your exception to be forced to be handled, you have to extend that from the runtime exception. Okay, so if you refer back to your lecture slides, I actually show you the hierarchy diagram as I show here in the lecture today. Okay, if you see that, you'll see. Okay, invalid transaction exception here. That's a new exception we have. So now we're going to see what happens. Okay, so if you go to the bank class over here, so bank class is the one that uses the deposit and withdraw method. If you see under bank, and you can see the deposit method here, so you can see the way we actually handles this exception. Remember in the lecture today, I actually talked about the catch or specify requirements. So every time when you are forced to somehow handle an exception, you can either catch or you can specify. So in this case, we are going for the specify solution, saying that as part of the signature of the method that uses this method here, which might throw some kind of exception, we simply specify as the part of the signature that it might throw the same kind of exception. Okay, so this is how we handle that. So we say deposit might throw invalid transaction exception. If you recall from the account class, you can see that the deposit here might also throw the invalid transaction exception. So the same kind. Okay. So that's also from last week. So hopefully you have seen that already. So we got bank, so we got deposit, and we got withdraw. And for the withdraw, we also throw the same kind of exception called invalid transaction exception. Okay, that is why we actually don't have to do any try and catch block yet. We'll do that in the next level. Okay, remember also in the class I actually drew the call stack, which shows you that the main method calls the withdraw in the bank, and the withdraw in the bank calls the withdraw in the account. So it's like a call chain that we are trying to execute. Okay, so now let's go to the bank application class. If you go there, you'll see that there's a main method here. So which means whenever you try to execute a Java project, the execution will start from here. So we create a bank object here, and then we create add an account over here, and then we ask the user to enter some amount to deposit. Okay, reading some double, and then we'd say try to deposit, and to the first account always. Okay, over here. So here, in the case where the amount is actually negative, let's say, if the amount is negative, then you actually will try to execute this deposit method here, and then that deposit method is going to call the deposit in the account. Okay, that's why you'll get the exception. Let's just review that. So if you put a breakpoint here, let's say, and then you would say run as debug as Java application. Okay, if you do that, enter an amount to deposit. If I simply say minus 100, for example, if I say that, you can say now I'm now stop at right before I do the deposit at the bank. Okay, so now if I say step into, and now if I say step into, you can see now I'm in the deposit method in the bank class. And if I step over, the first time I'm going to execute the deposit method in the account class. If I step into it again, so now you can see now this is the deposit method in the account class, and the error condition is such that the amount is negative. So indeed, so now the amount is simply minus 100. So that means the error condition will be satisfied. If I go there, you can see now I'm going to throw the invalid transaction exception. And just to remind you, if you go back to bank application, this is where we step into. Okay, so now because this line here will actually throw an exception object of type invalid transaction exception. So that means the rest of the try block will just be ignored. So we'll go directly to the catch block over here. Go directly there and see if this exception here will be matched. Okay, so now let's go back to the bank. Go back to the account actually. Go back to the account, and then if we say step over, it is going to throw the new exception objects. Okay, so now you can see, as I said before, so we just skip the rest of the try block, and we go directly to the catch block. So now the catch block is going to see the type of the exception object that's thrown from the previous code, which is invalid transaction exception. So this line here will be matched. Okay, that is why we'll go into it. So now we're going to print the error message here saying we actually got this exception here, so it's a negative deposit amount. Okay, that's what we had last time. Okay, now the first thing to show you, you can actually do better in terms of the error reporting. So there is one method in the exception class that will be useful for you to use. So let me show you here. You can simply say e.print stack trace. Okay, this is going to show you how the error actually got produced. Okay, we can try that and see what happens. Let's try that again. So this time, let me just remove the breakpoint and then see what happened. Remove it and then execute it. So now let me just say minus 100. So this time, it shows to me something that's more detailed. So first of all, it tells me that there was an invalid transaction exception object thrown from somewhere, and the error message is negative deposit amount. Okay, and here, this is the sort of cost stack I mentioned in the lecture today. So you can see, so this is the bottom of the stack, and this is the top of the stack. At the bottom here, we say that we started from here, the main method, and the main method was trying to call the deposit method from the bank, and the deposit method was trying to call the deposit method in the account. And from there, in line 14, if you click on that, it will actually bring you there. So you can see in line number 14, we actually throw an invalid transaction exception there. So somehow this is very valuable information to tell us how we actually got the exception objects thrown. Okay, so that's the first thing to learn today. So the print stack trace is really a method you want to use whenever you want to print off any error from your exception. Okay. Okay, so let me go back. Questions so far? No? Okay, so now let's go on. So now let's go to the package explorer here. So now we're going to make some changes here in terms of how we create the exception classes. Okay, let's try first of all the following. So here we have a single class called invalid transaction exception. However, this is not very detailed enough because in our case, if you go back to the account class, you can see there are three possible places that we can actually throw the exception or generate the error. The first place is when the amount for the deposit is actually negative. Okay, that's the first place. And the second place is where the withdrawal amount is actually negative. The third place is the amount is actually positive, but it is not, it's actually way too big for the current balance. Okay, so these are the three places. So we would like to somehow to have three kinds of exception classes rather than just one, just to be more detailed. Okay, so let's do the following. So let's do this. If you go to go to here, and then we're going to create new classes here. Okay. Originally, we just have one invalid transaction exception class. So now we're going to have different classes. Okay. So let me have the following. So go to Package Explorer here. So first create a class here. Let's say negative deposit amount. What just negative deposit will be fine. Negative deposit exception. Okay, and the superclass here always should be exception. Okay, if you do that, okay, there's a new exception here, and let's just, as usual, let's define its constructor. So it would say negative deposit exception here, and then we're simply just going to give a string argument here for the message, and then you will say super, and then message. Okay, that's what you would do. So that's the first new class we did, and then we're going to do another one. So here we got negative deposit, so we're going to get another one called negative withdraw. Okay, you can copy the code here, and we can use it later. So we can say new class, and then negative withdraw. If you do that, and then highlight this part and paste, we just have to change the name of the class. Negative withdraw exception here, and then make sure it has the same name as the constructor. Negative withdraw exception here. Okay. Okay, did I type anything wrong? Let's see. Negative must be defined in its own class. What does that mean? Let's see. Negative withdraw exception. Okay, I actually typed the name wrong. Okay, let me do it again. Let me just rename that. Maybe that will just work. So if you say refactor and rename, withdraw exception. I think that's what I need. Okay. So the class should be negative withdraw and then exception. So just a convention in Java. Always you have to end the name with the exception. Okay. So now we got two classes. So now just got another one. So let's say we got another one called, so class, let's say insufficient balance. Let's say you want to withdraw some amount, but somehow your balance is way too small for you to withdraw. So it's called insufficient balance exception. Okay, and now you're going to have the superclass being exception. Okay, finish. Okay, so declare that constructor there, and then you have string message, and then you have super, and then message. Okay, that's what you have. So now you got three classes here. So you got invalid transaction exception. That's the original one. So now we can delete it. Okay, I'm gonna show you how we can plug in the three new ones we just did. Delete that. So now basically we got insufficient balance exception, we got negative deposit exception, we also got negative withdrawal exception. So now let's see how we can do it. First of all, go to the account class. Okay, so now we're gonna say in the case of deposit, we're going to throw the negative deposit exception here. In the case where the amount is negative, so we'll throw the negative deposit exception. Okay, and now in the case of withdrawal, we're going to throw two kinds of exceptions in this case. So you might throw the negative withdrawal exception and also the insufficient balance exception. Insufficient balance exception. Okay, so if you want to, so if your method can throw more than one exception, separate them by comma. Okay, that's what you got to do. Okay, and now, so now let's change the code a little bit to say, in the case where you actually got a negative amount, in this case, you're actually going to throw the negative new negative withdraw exception. Okay, so now you can say negative withdraw. Okay, so now else if the amount happens to be positive, but your balance is actually not enough. In this case, you're going to throw the insufficient balance exception. Okay, so you can say insufficient balance. Okay, so this is the three possible exceptions we might have from this class here, account. So in the case of the deposit, you might throw negative deposit exception. In the case of the withdrawal, you might throw two possible exceptions. One is negative withdrawal. The other one is insufficient balance. Okay, either one of them. Under different circumstances. Okay, let's we're finished with the account. Let's go to the bank. If you go to bank class over here, you will see that over here. So now, again, so now you can see the deposit over here is trying to use the deposit from the account. So in this case, we just want to say we don't want to handle the exception just yet. So we simply just want to somehow just to specify, remember the catch specify requirements. In this case, we just want to specify as part of the signature that we might throw this exception. So you would say throws negative deposit exception. Okay, so now we can actually, so that's how we handle this, okay, temporarily. Okay, and now in this case, similarly, we're going to say negative withdraw exception, and also it might also throw the insufficient balance exception. Okay, so these are the two. You can separate, you can put it in different line, that's fine. Okay, so now, for example, as part of the signature of the withdraw method here, which says that normally it wouldn't return anything, but if there's any exceptional event occurring, then we might throw either a negative withdraw exception, or we might throw the insufficient balance exception. Okay. So now let's go back to our bank app and see what we should change. If you go to the bank application here, so now let's maximize that. Okay, so now somehow you have to say, because now you can see you're trying to call the deposit here, which might throw the negative deposit exception. And here you're trying to call the withdraw method here, which might throw either the negative withdraw exception or the insufficient balance exception. So there are three possible exceptions that might be thrown from the try block. Okay, so what we can do over here, so what we should do is to enumerate all the possible exceptions that might be thrown from the from the try block. Okay, and handle them one by one. So what you should do here is to say catch. Doesn't matter the order in this case. Okay, you would say catch. So negative deposit exception, you just declare that to be E here. And then you can actually print some warning to the user. So system.out.println. You can say, in this case, you can say amount, deposit amount, and as you can see, we actually read the amount before from the input. So it's over here, I think, the amount. Okay, I believe we can simply use it here. Is negative. Okay, and then we can also use the method I just mentioned. So you can say e.print stack trace. Okay, that's how we handle that. And the way to handle negative withdraw exception will be similar. So now we just have to change that to say negative withdraw exception here, e. So now we can say withdraw amount is negative. Okay, and one more. The third one that's possible is simply if you do insufficient balance exception here, and now you can actually say we can print a little bit more information here. We can say somehow what the current balance is, and we simply cannot afford for such a withdrawal. Okay, is too big. Okay, and then let's print another line here. You can say system.out.println. You can say something like current balance is, and then you can say b.accounts, the first account we were trying to withdraw, and then dot balance. Okay, just as an example how you can handle the exception. Okay, so now let's try and see what happens. First of all, let's try if we simply enter minus 100. In this case, you can see now we actually got more error message here. We say deposit amount minus 100 is negative. And then we also got the stack trace actually from the exception. Okay, that's the first kind of exception we might get, which is negative deposit exception. Okay, let's try the second one. Let's say we deposit 1,000 into the account. Okay, and now let's say we would like to withdraw minus 200. In this case, we get the exception there saying withdraw amount minus 200 is negative, and that's correct because we actually got the negative withdrawal exception thrown. And this is stack trace for that. You can see we go from the main method, and then the withdraw in the bank, and then the withdraw in the amount. Okay. And let's go on. The third kind of error we might have is, let me relaunch the program here. Let's say we deposit 1,000 into the bank account, but now we would like to withdraw some positive amount, but that's too big. Okay, let's say 2,000. In this case, they would say withdraw amount 2,000 is too big, and this is the exception we got, insufficient balance exception, and then he also gives us the stack trace. Okay, so that's about how you can create multiple exception classes for yourself to use. Okay, so now as we also learned from the lecture slides, so every exception class we have so far is a subclass of the exception class. Okay, so now if I somehow replace, for example, let's say this block of code here and say catch exception E. So now I'm saying I can now catch any kind of exception as long as it's a subclass of the exception class. As I also said in the lecture before, when we actually want to match the exception, it is as if it is running an instance of operator to check to see if the exception object that is thrown from the try block is actually an instance of the exception. As long as it is, then we can do something about it. Okay. So now, for example, we can say, well, if it is negative deposit exception, then we do it accordingly. If it is negative withdraw exception, we print the appropriate message. Otherwise, if it is any kind of exception, then we simply say, well, just some exception. Just want to show you. So you can say system.out.println. Okay, you can say, for example, you can say exceptions other than negative deposit and negative withdrawal. Okay, just to show you like how it will be run. E.print print stack trace. Okay, the same as before. So now that should be E here. Okay, so now if you run it, you will see that. So now let's say we enter 1,000, and then let's say we try to withdraw 2,000 from there. So now you will see now we won't get the first error message, the previous error message that we got, which is insufficient balance. So now it will simply say exceptions other than negative deposit and negative withdrawal. Okay, and it is the insufficient balance exception we got. However, the error message is different. Okay, it's simply because now we change this to be exception here, so it will simply just go there no matter what. Okay. So now one more thing to show you. Before we move on to a new example. Let me put this back. So let's say we still check the 3 possible exceptions here. Let's say if we put exceptions here, okay, so somehow Eclipse is very smart. Somehow it's smart enough to actually tell you that this wouldn't compile. Okay, let's see why. Somehow it will tell you that unreachable catch block for negative deposit exception. It is already handled by the catch block for exception. Okay, you should really understand why this is the case. So remember what I said before. Whenever there's an exception object thrown from the try block, Java runtime will try to match that exception object with the type of each of the catch block one by one. Okay, starting from the top and moving gradually to the bottom. So the problem is because every exception object is an instance of exception class. So that is why this block will be matched, always the case. So that's why you will have no chance to actually bypass this block here and then go to the subsequent catches. Okay, you should really review the slides if you don't see what I mean. Okay, that's actually what I said in the slides meant. Okay, so Eclipse is actually very clever. It actually tells you that. So you cannot put the exception here. You can only put such block at the end to say whatever unknown class I have there, I will catch them here. Okay. So here you can change the error message here to say any unknown exceptions. Okay, so that's about the how I want to modify the last week's example, just to play with it. Any questions? If you actually didn't follow last week's exercise, you should really catch up because Friday's quiz will be based on that. Okay? Yeah. Friday's quiz will be based on today's and also last week's exercise on the exception. So, okay, that's good. So let's do something quickly, okay? So now, can we just do another example here? So I want to show you the difference between exception and runtime exception, okay? So that's something I also want to show you. So let me just show you a diagram again. So that's the diagram I showed in the class today, but it will be worth showing it again. So if you go to a slide, which I will post very soon. Sorry, not this one. So not this one either. So I think the one I want to show you is this. So this is a very important diagram for you to understand. Okay, so in this diagram here, so there are 3 classes you have to pay attention to. So the first one is the error class, the second one is the exception class, and the third one is the runtime exception class. So 3 classes here. As you can see, the runtime exception class is a subclass of the exception class. Okay, so let's say what we did before. For example, let's say, remember we actually got insufficient balance exception extends exception. That means it is put somewhere here, okay, where I actually moving my mouse over. So over here. So the insufficient balance exception is a direct child class of the exception class. Whenever you have any class that's under exception class over here rather than under the runtime exception, that means those kind of exceptions must be handled explicitly, following the catch specify requirements, as I saw wrote on the slides. Okay, in the case where you define your exceptions as a subclass under the runtime exception, under this part here. In that case, your exceptions do not have to be explicitly handled. So that's the tricky part in Java. Okay, that's something you have to pay attention to. Now I'm going to demonstrate to you using a very simple example just to show you. Okay, so let's create a new package there. Okay, so it's very artificial example, but I think you will illustrate the point. Can we just create a new package there? So let me just say checked versus unchecked. So I'm going to illustrate to you the difference between checked and unchecked exceptions in Java. Okay. So let's just do something that we're familiar with. What about just do the checked exceptions first? So let's create a new class there. So what about we just say and exception, okay? And we're going to make the superclass exception as before, like an invalid transaction exception or the insufficient balance exception, something like that. Let's do that. So now let's declare the constructor as usual. So and exception here, and then string message, and then we say super message here. Okay, no surprise, just the same as before. So now if you go back to the package explorer here, so let's create some class over here. So what about we say a class called A? Okay, just A. Okay, class A over here. So now let's say we have a method in A. Let's say AM. So method in A, AM. Okay. So now let's say we have method in AM in A. Over here, let's say this method here might throw an exception. Okay. So the way to do that is to say this throws an exception. Okay. And then we say, so when do we throw it? What about we put a parameter for that? Let's say integer I. In the case where I is less than 0, then we're going to throw new an exception. And then you can say negative integer. Okay, just make it simple. Otherwise, let's say otherwise we simply just actually it doesn't matter. Otherwise we do something, but I don't have to specify what it is. Doesn't matter. Okay, I just want to illustrate to you what does it mean to be a checked exception. Okay. Okay, let's go back to our package explorer here. Let's create one more class over there. So now create another class called B. Okay. So now class B here, let's have a method here. Let's say BM. So method in B. So now let's try this. If somehow you're trying to use the AM from class A, remember in class A, the AM, you actually might throw an exception. Okay, let's see that. So you can see A, object of type A, is equal to new A. First of all, do that. And then if you say A.am with some integer here, let's say also you have some integer here, I and I here. Okay, so this is actually what a check exception is about. Let's see what the error message is here. Apparently the code doesn't compile. If you see that, it says that unhandled exception type an exception. Okay. The reason is you can see the method am here as defined in the class A here. It throws an exception. And when we first created an exception here, it extends the exception class, which belongs to this category over here. So it's not under runtime exception. So this is so-called a checked exception. So you should really check the slides. So that's the first category of exceptions, which must be explicitly handled. Okay. So now there are two ways for us to handle this. So if you go back here, so there are two ways to do it. I'm just show you both, and then I'll move on to the runtime exception. You can either say, so it's going to follow the catch specify requirements. Either you can say specify, so I would say throws an exception. So this will make it compile. Simply means I'm not going to handle this an exception object right away. I'm going to somehow pass this or to forward this exception to the next level. So if you see my slides, I actually also got some call stack diagram that shows you. I think it's actually quite clear if you see the diagram, what happens. This is approach 1. Approach 2 is to say, I would like to handle this exception right now by using a try and catch block. So I would say try this line here, which might throw an exception. And I can say catch and exception E. And then once I catch the exception, I can say E dot print stack trace. Okay, if you can see that there are 2 ways to handle this exception here, which must be explicitly handled. Either you can follow the catch specify requirements. Either you can catch using a try and catch block, or you can specify by extending the signature of BM. Either way. So, it's really up to what you need. Okay, this is about the checked exception. As you can see, either one of the approaches must be followed, otherwise your code wouldn't compile. Let's try the case where your exception is actually a runtime exception, in which case you wouldn't have that kind of inconvenience. Okay. Let's go back to Package Explorer here, and now let's do a new class here. New class, let's say a runtime exception. Okay, there's a new class here. And now this kind of superclass is no longer the exception class. It's going to be runtime exception. Okay, and say finish. And now, as before, we're going to declare the constructor here, a runtime exception here. And you got string message. So here you got super and message. And okay, similar as before. Okay, so now let's do a new class here. So we used to have A and B, so let's have C and D. So let's have class C here. Okay, in class C here, let's say we have a method in C. Let's call CM. So let's say again we take some integer here. Okay, so now we're gonna say the following. So let's say if I less than 0, if it is negative, then we're going to throw new a runtime exception here, and then we're going to pass some message here. Let's say negative integer. Surprisingly, okay, if you notice that, surprisingly, this already compiles. Okay, you can see this already compiles, which means we no longer have to extend the signature of CN to say it throws a runtime exception, which is in contrary to the case for class A. Let me remind you about it. If you go back to class A, you can see that here we say throw new an exception. In this case, if you simply take it out, let's say, it's going to complain. Okay, it simply says that you actually throw the exception here, but you did not actually declare that in your signature. Okay, that's a problem. So this first illustrates the difference between an exception and a runtime exception. Okay, so if you go back to where we were, so class C here, so here we no longer have to say that anymore. Okay, so now let's go back to Package Explorer here. Let's create a new class. So new class, and then we say D. Okay, now in class D, we're going to have the following. Let's say void dm, okay, method in D, integer I. Okay, so now I'm going to have the following. Let's say I simply do create a new object here. Let's say C equal to new C, a new object of type C. And then I say C.cm. And let's say -10, for example. And remember, Cn, as we declared, might throw a runtime exception, as we can see from its body implementation. However, in D here, although we are using that, but Java compiler didn't complain. Somehow the code compiles, so we didn't actually have to try and catch the potential runtime exception. Neither do we have to extend the signature of DM to say it might throw a runtime exception. Okay, this is really what I meant in the lecture by saying whenever you actually have any subclasses of the runtime exception, then it doesn't have to be. It won't be forced. You won't be forced to actually handle that. Okay, that's why. You can actually also see the description for each category, so I wouldn't say that again. So you can see the slides. Okay, so this illustrates the difference between the two kinds of exceptions. So either a subclass of the exception class, or it can be a subclass of the runtime exception class. One is checked, the other one is not checked. Okay, so I would like to do just one more example. Okay, just to show you that how the exceptions are thrown, and also show you some stack trace example. Again, let's create a new package here, and this example again is going to be a little bit artificial, okay, contrived, but it will illustrate the point. Can we create a new exception here? New package here. Let's call that stack, call stack, for example, call stack. So that's the thing I would like to illustrate. Just call it call stack. Okay. So now we're going to create 5 classes. Okay, and then somehow we want to show the chain of method calls between the classes and see how the exceptions might be propagated throughout. Okay, that's something I would like to illustrate. Okay. So let's just create 5 classes first. So let's do C1, C2, C3, C4, and C5. Okay. I'll try to make the method simple so you can actually focus on the points. So let's say we got C1 in call stack. Let's say we got C2, C2, and also we got C3. Okay, and also we got C4 and C5. And we got C5 over here. Like that. Okay. So let's say we have a kind of exception there that must be handled. Okay. So let's create a new class here. Let's use the same. Let's say an exception. Okay. So here the superclass is going to be exception. Okay. So now we have this class here, an exception here, and just redeclare the constructor here. So an exception here. So we got string message, and then we got super message. Okay, that's what we have. So let's say now we have C5. Okay, let's start from C5. Let's say C5 is a class where you might have the exception thrown. Okay, let's say we have M5. Okay, just make the number correspond to each other. So let's say we have void method here, M5. Let's say it's always going to throw the an exception. Throw new an exception. Okay, and an exception here. Okay, in this case, because an exception actually is a subclass of exception. So in this case, you must handle that. So in this case, we simply say you have to say it throws an exception. Okay, that's in C5. Okay. So now, whoever is going to use the M5 from C5 must explicitly handle that, because now an exception is actually a direct subclass of exception. That's why. So let's see how we can do that. So now, let's say the following. If you go back to C4, okay, let's say in C4, we have a method there called M4. Okay, and in C4 here, we simply create an object C5. C5 is equal to new C5. Okay, and then we say C5 dot M5. And of course, this is going to be a complaint because it says that you have not handled the exception of type and exception. Okay, let's say we don't want to handle at this level yet. Okay, let's simply say throws and exception. Oh, sorry, wrong place. Should be at a method level. Throws and exception. Okay. Similarly, let's say we go to C3 here. So now C3, let's say, is going to use C4. Remember, C4 dot M4 actually throws the an exception. So let's say now in C3 here, let's say we have a method here, void M3, and then let's say here. So if you create C4 is equal to new C4, and now you say C4 dot M4. If you do that, again, it's going to complain because M4 declares that it might throw an exception. So an exception is a checked exception, so you must handle that. So let's say we don't want to do it now, do it yet. So you can say throws and exception. Okay. So let's go further. Let's say for C2 as well. Okay. So now let's say we have void M2 here. So now similarly, so let's create C3. C3 is equal to new C3. So now we got C3 dot M3, and it's going to complain for the similar reason. So we'll simply say throws and exception, and of course this has to be at the method level. Okay, so now finally, let's say we go to C1. Let's say in C1 here we do have a main method here. This is the entry point of execution. Okay, so here we're going to create a C2 object here. C2 equals new C2. And then we have C2 dot M2. Okay, let's say now we are at the in the beginning of the call chain, sort of at the bottom there. So this is the entry point of execution. So now we're trying to use M2, and M2 declares that it might throw the exception from M3. M3 in turn declares that it might throw the exception from M4, and all the way actually down to M5. So that's the call stack. So now there are two ways to handle this, as I said in the lecture. So either you can just go further and say, well, I simply just say this main method here might also throw an exception. In this case, the runtime, so when the exception object is thrown from M5 in C5, the runtime is going to search through the proper exception handler to handle this. But it will go all the way from M5, M4, M3, M2, M1. You couldn't find anything. So that's why it will simply throw the exception to the console, as I explained in the lecture. So if you try that, you will see that we simply got exception in the main. Okay, and that's the sort of an exception here. So you can see this is actually the call stack over here. So you can see we start from C1.main, and then we go to C2.m2, C3.m3, C4.m4, and C5.m5. Okay, that's a call stack. Okay, so this is the case where you didn't choose to use the try and catch block to handle that. So let's try the other way. Let's say rather than this, we're going to do the following. So we're going to use a try and catch block. So we're going to try this line here, which might throw an exception. And then we'll say catch and exception here. And then we're going to, okay, an exception here. And exception E. Let's say that. Okay. Let's say in this case, we simply just do system.out.println. Okay, we can say exception from we can see M2. Okay, it doesn't matter. So somehow you just want to show that you can actually handle that. You just don't want the exception to be thrown directly to the console. You just want to print some error message there. Okay. So now if you do it, you can see somehow you got a different message here. So you really have the whatever message you would like to print out. So it's actually proper handling of the exception. Okay. So now let me show you that the following. let's say so you can see the call chain we have is go from C1, C2, C3, C4, and C5. And currently we'd say that the exception was actually thrown from M5 in C5. And we said that in C4, C3, and C2, we simply didn't try to handle that using the try and catch block. We didn't do it. We simply just propagate, which simply forward the exception objects all the way to C1, and then we handle it there. So let me show you one possibility where you can choose to handle that earlier than later, okay? So let's say we do this. Let's say C3 here, let's say we try to handle that there. So now let's say we get rid of the throws and exception here. So of course he's going to complain because we haven't handled that yet. But now we would say the following. We'll say try, and then we would say C4.M4. And then we'd say catch. And exception E here. So now we can say print some line here. System.out.print line. And then we can see end exception handled in C3.M3. Okay, so now if you go back to C2 now, you do not have to say this anymore. You can just get rid of that because the exception has been handled in C3. So that's why when you are using M3 here, so now if you look at M3, it does not throw an exception anymore because you have handled that already. Okay, so if you go back to C2, go back to C1. So now you don't need this either. So you can simply say C2.M2, and you don't need that try and catch block anymore. Okay, so now let's give a try. Okay, to actually go slow down, will be slow in this. Put a breakpoint here, and now let's do run debug as Java application. So now we are now in C1 here, and now we're trying to use C2.M2. So let's walk into it. So now we are in C2, and now we're trying to execute M2. If you step over, so now we are trying to call C3.M3. If you step into it, oh, sorry, let me do it again. I clicked the wrong button. So let me do it again. So run debug as, let me just go back to Java perspective, and then go back to C1, and then run debug as Java application. So now let's step into it. So now we are in C2, M2. So step over, now step into M3. So now this is the place where we might have the exception, but we try to handle that already. So now you can see we created a C4 objects, and then we step into it. So now we are in C4 over here, and now we have C5 objects, step over, and now we step into the class where, in the method where we throw the new exception. Okay, that's an exception that's being thrown. So if you step further, exception has been thrown. So now you can see the catch block that we defined in C3 actually caught the exception. So that's why the exception was not just forwarded to the upper level like a C2 and C1. Okay, that's why. You should really compare how we did things, before and after. So that's how you understand the exceptions. Okay, go ahead, and now we say catch, and now we're gonna print an exception handled in C3.M3. Okay, that's what you get. Okay. Yep. Okay, that's basically what I wanted to say. Any questions? Okay, if you have no questions, then I think that'll be it for today. Okay, try to redo the examples yourself. So I try to go very slowly with you, but you really have to try it out yourself. So you have to study today's exercise and also last week's exercise together well, and also to go through the slides in order for preparing for the Friday's quiz. Okay, if you got any trouble, come to my office hour either tomorrow or Thursday, or make an appointment if you like. Okay, so I'll see you on Wednesday. Yes, I'll see you on Wednesday.